All right, welcome everyone. Welcome to the stream and today's session on Raiden. I'm Shannon, part of the global team, and I'm here joined by André from Raiden. Very nice to have you.
Thank you. It's very nice to be here with you as well, with you guys.
Yeah, so super excited for this one. André, you can feel free to take it away. But as for questions, please feel free to post them either in the YouTube chat or in the Zoom chat. We'll answer questions right after the main presentation is up, but feel free to ask questions anytime. Thanks, Don.
Okay. All right, André, I think you're good to go.
Okay, so hello everyone. My name is André Vitor. I'm from Brazil. I'm 29 years old, software engineer, living currently in São Paulo, and working for BrainBot almost 4 years now in the Raiden team, which is one of the first scaling solutions for Ethereum. And we will be presenting the results and some code walkthrough and demonstrations over the latest Raiden Light Client, as well as a background on the payment channels network technology for scaling payments and transfers, and presenting the Raiden protocol, and then some hands-on demo. So yeah, let's start. I'll quickly present my screen. I won't ask if you guys are seeing it because it works every time. So I just assumed so. So Raiden protocol and the Light Client implementation and client. So let's start first with the payment channels. I'll just do a quick intro so everyone is in the same page after this. So as everyone knows, and this has been the hotspot of the debate from scaling solutions and blockchain technology, which is layer one scalability issues, which mostly comes out of the requirement for global consensus. So what this means, that everyone needs to agree on the current state of the network, or at least after on a given path for a given state in the past for the current the state of the Light Client of the blockchain state and the account state, balances, contract states, and so on. So this requirement for global consensus is the strength of blockchain technology because it's fully decentralized, but it's also its Achilles knee because it's hard to actually ensure this consensus in a safe way without while still keeping the workflow and the flow of transactions going steadily. So yeah, this mainly caused or was the main improvement and the technology breakthrough from blockchain is it started with the proof of work algorithm, which allows anyone to propose blocks and to have them accepted over these consensus rules, but they can be reorged, and proof of work is what dictates what's the latest and most up-to-date view of the state of the blockchain. And in order to have your transaction safely settled on the blockchain, you need to wait for a specified amount of time, a specified amount of blocks, which means that there will be a low probability of this getting reorganized and your transaction going out. But of course, this makes the number of transactions and the ensuring validating this consensus a bottleneck of the network because global consensus is required. So payment channels is a scaling solution for layer 2, which uses layer 1 deposits to reduce the consensus requirement from global to local. So there are local channels, which is an abstraction. Those channels are an abstraction. And you only need to have consensus over this local channel with your partner. So if you have a channel with someone, you only need to agree with them on the current state of your channels, or the current tokens, or any kind of asset transferred to them back and forth. You don't need to inform and to have everyone agreeing on this state of this local perspective of this limited set of the blockchain state. In this case, it's the channel state, the deposits going in each side of the channel and being transferred back and forth between the partners. So payment channel networks, they allow you to transfer to nodes that you don't have a direct channel with, because if you have to open a channel with every peer you want to transfer assets to, this would be extremely slow and also capital inefficient, even more than what we already have, because you would need to lock that the number of channels, the number of tokens in a channel with everyone that you intend to transfer tokens to. So with a network of payment channels, instead, you are able to keep only a limited number of channels and to mediate payments through these channels networks. So if you are connected with a partner that sometimes is called a hub, that have several channels, for example, 5 channels, or is overall well connected and balanced with the network, you are able to transfer to nodes that you don't have a direct channel with by transferring to them with specific instructions on how to forward these payments forward and to get it to your target. And only after that, you would be settling those tokens. They would be forwarding this as well to the next mediator, and then the next mediator, and so on. So the advantage of payment channels network is that the throughput, or the transactions per second, transfers per second in this case, increases linearly with the number of participants. Instead of getting hindered by the number of participants and the number of payments and transfers going through the network, this would actually increase linearly with the number of participants. So as many participants are participating in the network, as higher the capacity and the throughput of this network, this layer 2 network. So here is my example. Alice and Bob, this is an example for a channel, a payment channel. They have a smart contract which dictates how the rules for this payment channel, and each side can deposit a ERC20 tokens, for example, on their side of the smart contract. And then they deposit only once. They open the channel. This is one transaction. They deposit these channels. It's one transaction per each side. And after that, they can do an unlimited number of transfers going back and forth in these tokens between them without having any on-chain transaction in this meantime. Of course, as long as these transfers are backed by their respective deposit or their respective balance. So you can, if you have received all tokens from Bob, Alice can actually transfer all that they had deposited plus all that Bob had transferred to them. She can transfer to Bob or can transfer to someone else through Bob. So this is a small demonstration of how a routing a payment works. So there is a service that will give you a path in this network of well-connected nodes, and then you'll be able to route payments only through channels that through partners that you have a direct channel with, right? Yes. So yeah, how the Raiden network implemented this. So payment channels is a more or less generic idea. This is actually the same idea behind the Lightning network from Bitcoin. And Raiden network, as I said, is one of the oldest implementations of a scaling solution for Ethereum on the Ethereum network, layer 1, Ethereum 1.0 so far. So the Raiden network, how it works. It's mostly composed of a set of contracts deployed on Ethereum mainnet and also on all the test nets, mainly Gurley. It's the main network that we use. It uses a federation of metrics.org transport servers for off-chain communication between nodes and discovery, as well as it trusts this federation to be able to connect direct WebRTC peer-to-peer communication channels between nodes, so they can talk more efficiently and faster through those peer-to-peer RTC channels without actually having to go over the metric server. But the fallback, the last layer of communication, of off-chain communication, goes over metrics, which is very reliable in the sense that it can be reached, since it uses HTTP pooling in the background. It actually can be reached behind net, over mobile clients, as well as on Node.js and several platforms. There are several libraries implemented everywhere in order to communicate with Matrix Federation of Servers. This federation currently is not connected to the main metrics.org federation, but it's open and currently just a created list, but eventually this will also be registered on chain, the list of currently participating nodes in this federation. The transport servers are free, are provided by community, and we ensure that this will continue working. So besides the free transport servers, we have a set of incentivized services provided to the network, namely pathfinding and monitoring services. Pathfinding is responsible to keep a bird's eye view of the network topology, as well as capacities, and being able to find the most efficient path towards your given target on this network. And monitoring service, of course, is responsible for allowing partners to go offline without incurring the risk of losing their received assets. Because since this the payment channels only require local consensus, any node participating on it and willing to keep their received assets would need to be online 24/7. And that's why we need those monitoring services. On Lightning Network, it's called watchtowers that are going to act on your behalf, properly incentivized, in case it's needed to act in case the partner has closed the channel while you were offline. So currently we have two major clients implemented already in two different languages. We have the Raiden Python implementation, which is the first reference implementation, mostly focused on servers and personal computers, as well as the Light Client, which we call the Light Client because it's written in TypeScript, transpiled to JavaScript, and intended to work in browsers and Node.js environments. But it's not a light client in the sense that it depends on a full client to work. This is actually a full implementation of the Raiden protocol in the form of an SDK or a library that we call Raiden-TS, and two major interfaces for it, user interfaces. So the DApp is a web UI interface, user-friendly, and the CLI is a RESTful Express Node.js API client, which is compatible with the Raiden Python RESTful API. So it's interchangeably, both clients can be interchanged accordingly, and still be able to work on the same applications together as the backend of any application built using those Raiden REST API. So yeah, this is more or less how it's built, the network schema architecture. So we have a core of nodes that are well connected to each other here in 1 and 2 and 3. And we have light clients, or it could not be light clients, but any client that is not willing to actually deposit and commit the funds on several channels. Instead, they open a smaller number of channels with the core of the network. In this case, A and B could be light clients working in the browser, running in the browser. And pathfinding service, as I said, is responsible to keep a view of this whole network topology and be able to find the path between A and B, for example, when A requests it. As well as when B receives a transfer, it will be updating monitoring service with the latest balance proof that it's received, and then they can go offline safely, and monitoring service will act if N3, in this case, the partner, closed the channel with B while B was offline. So yeah, this is the Raiden protocol. The Raiden protocol mediates transfers on this network of payment solutions using locked transfers, or a hash time lock mechanism, where A, after getting the path between him and D, which is the target, through B and C, but they only have a channel with B, they then compose a locked transfer to B, having D as target and going through B and C. So B, upon receiving this locked transfer, creates a similar locked transfer to D through C using the same secret hash. And then C does the same. When D receives the transfer, identifies itself as the target and A as the initiator. The target requests the secret for that specific transfer from A, and then A can reveal only to D through transport the secret that hashes to that secret hash for this hash time lock mechanism. And then D can safely reveals the secret to C in order to claim an off-chain payment. If C, for any reason, does not want to cooperate on this off-chain protocol and tries, for example, to become unresponsive, D can go on-chain and register the secret on-chain, and then they are sure, as soon as they have received the secret, that they will get paid. Because if C does not collaborate, they can go on-chain, register the secret, and this will allow them to then, later in the future, when they want to settle the channel, to claim those tokens that were received on this specific transfer. C, upon receiving the secret, of course, needs to now knows that D has the capability of going on-chain and requesting this payment if needed. But to avoid that, the need for that, they unlock the transfer to D by sending an unlocked balance proof to D with the same amount that they had previously sent. But now C also knows the secret, so they can reveal back to B, B unlocks to C, then B reveals back to A, and A unlocks to B, and then you got a payment fully safely mediated payment through this network between A and D, without actually then having direct channels between each other. So with only a channel with B, A was able to transfer to D as soon as they knew the route, and they managed to perform this off-chain protocol through signed messages between each other. So how the Raiden actually a Raiden transfer workflow works. So the client needs to deposit to UDC if they want to pay for a route from PFS, or if they want to have monitoring service monitoring their channel, and they are willing to, they are need to go offline for any reason. Of course, it's after depositing to UDC, they also need to open a channel in order to transfer tokens through this network. They may check that the target is online in order to, that if the target is offline, they don't even need to start the transfer, since it's not going to succeed anyway. Both nodes need to be online in order for the transfer to work. And then they need to get a route that if it's a direct transfer, so between partners connected through a direct channel, they don't need to request a route because they know that the partner is or isn't online. Or if it's a mediated transfer, they request the PFS and pay for this request, a small amount with several orders of magnitude cheaper than on-chain transactions, in order to route this transfer through the network. Then they initiate the transfer. If it succeeds, it should succeed quickly, or else it's going to keep retried until it expires. When if it, for any reason, it happens that the transfer expires before succeeding, or for example, the sender went offline, or for any reason, after they come back online, they see that the transfer failed, and they are able to sign lock expired message and make their locked transfer liquid again. So there's a small locking amount, usually around 12 minutes, that where these funds are virtually locked in this channel and this transfer, even if it has not succeeded did not go through. But after that, they can just expire it and get back their funds, and then do whatever they need to do. Maybe try another route, maybe withdraw these tokens from the on-chain channel. Upon receiving a transfer, of course, the node needs to update the monitoring service if they plan to go offline or for any reason. If they are staying online all the time, for example, which is the case for full nodes, they don't need to update the monitoring service, but it is highly advisable. Since this, as I said, this is just local consensus, this is a requirement for this network. So how is the actual light client architecture? Its primary target platform are browsers, which contains the most restricted set of interface, and it's the most secure, or they strive to be the most secure platform because it has the highest exposition to clients and to applications, web applications running anywhere in the web. The browsers are quite restrictive on security features, and therefore it's hard to make something truly innovative and cryptographically safe to actually work on browsers. So we choose to target browsers because this limited set of assumptions, so a browser tab or a browser application is not always online. It does not have good guarantees on persistency and so on. So our idea is, if it works in the browser, it should work anywhere. So the browser is the most limited set of features, and then after that, if it works in browser, it should be easier to have some more relaxed assumptions, for example, for mobile and embedded devices, as well as servers and personal computers. We also target Node.js, since it is a quite common platform denominator and available from IoT devices to servers. And the client is fully written in TypeScript and is type safe. As well, it's transpiled to JavaScript, so it runs wherever the JavaScript code can run. So the SDK, or the library, Raiden TS, is in the base. It communicates with the Raiden network and Ethereum blockchain. And its interface currently is the dApp and the CLI. So yeah, you can use the dApp directly. These are the main ways for you currently right now to use the dApp, the Light client. So you can use the dApp directly. It's kind of a PayPal-like experience where you can redirect the user to the wallet, the Light client dApp, where they will perform their transfer. So you can pass token, target, amount, and even payment ID over parameters. They will perform their transfer on this deployed dApp instance, and then you can detect that on your system on the backend and react accordingly, for example, by providing them for the resource they just paid. You can also use the CLI, which is a Node.js client, but this is mostly intended for servers and backend implementations, since this needs to be running should be running 24/7 most of the time. And you can also import and instantiate the Light Client SDK directly. So the Light Client SDK is a quite easy to use API, where you can use and implement a fully new client by leveraging the Raiden protocol heuristics and algorithms implemented in the Light Client SDK or Light Client Raiden TS library, which is available on npm.js. So this is the most powerful approach, but leaves more decisions to the developer. So with whom to open a channel with, how many tokens to deposit on UDC or on a channel, and so on. The concept of it is that if it's running on web, this mostly uses IndexedDB to keep state, because the Light client, of course, since this is not global consensus, it's stateful, so it requires some state to be kept on your client. since this state is isolated by origin or website, if you do that on the web, you are going to require from your user to do the onboarding for each instantiation, each implementation, each part, each place where you implement this. While if you use the dApp directly, you can rely on the state being shared. So let's do a quick demo. First for the dApp. So let me just refresh this. This is a dApp instance. You can access it at https://lightclient.raiden.network. And this is a PWA implementation in client, so you can install it on your system and run it fully offline. But let's not do that now. Once you connect, it will generate a private key, which is actually derived from your main MetaMask or whatever provider you are using, main MetaMask account. This is created by signing this message here, which gives you a warning that you should not sign this message outside of this domain. So it's specific per blockchain, per network, and per domain. And you can just sign it, and it will log in, and it will, all the tokens and Ether used for on-chain transaction is still offloaded to the main MetaMask main provider account. So you can use it from Gurley here. So you can keep your stash still on your main account, which is interactively prompted for any transactions being done, being made. But of course, you can this subkey account, which you can see here, is different from my MetaMask account, which got generated. This account here can be used only for signing the messages that go back and forth, because you can actually use the MetaMask account directly, but then you would need to sign several messages in order to perform a single transfer. So let's do a small transfer. You can see here and that I have a single channel with 30 tokens of this test token deposited on it. The state is open. You can just type an unanswered address here. For example, this is my hub, my partner address. So I'm going to perform a direct transfer since I'm transferring to someone that I already have a channel with. So let's do 0.1. You can see that it skipped selecting the route because this is a direct transfer. So I don't need to request a route. Then let's perform a transfer. The secret gets revealed on chain. Oh, the secret gets revealed to the partner, and then the transfer was successful. This usually takes between half and 4 seconds, depending on network conditions. I'm in Brazil right now. The hub is on Germany. So it takes around 4 seconds to perform this transfer. So, but you can see here, this is still way faster and was completely free once the user has onboarded. So this is the client. You can manage your channels here if needed. You can close it and settle it in order to withdraw the tokens from the channel if needed. Besides this, if you don't want to use the deployed instance of the Light Client Raiden Network client, you can also use the Raiden SDK and Raiden TS, which is the engine for the Raiden protocol here, written in TypeScript, as I said, and running fully in the browser. So it's not offloading tasks and responsibilities to a full client somewhere. This is running entirely in the browser. Signing out the messages cryptographically, verifying on-chain events and signatures, everything running in the browser. So here I have the smallest possible Raiden Light Client implementation using the SDK, just to showcase how it works. As you can see, this is just the simplest possible HTML with the simplest possible almost package.json. And this is the whole source code. So yeah, most of it is just this function here, right? You can see the whole onboarding process happens here. I already have this account onboarded, but I will show to you guys. So first you need to connect to MetaMask by requesting the account from it. When you do that, if you haven't connected to the website yet, you get notified by MetaMask that this website wants to access your account. You can select the account that you want to provide, to offer. Then you can instantiate Raiden here. There is a nice utility here where you can just pass the provider. Here we are telling Raiden that we will want to use the first MetaMask account for it. You could specify a specific address or private key directly here if you want, and so on. Then we subscribe to channels updates, and we start Raiden. This will sync the state if needed with the blockchain. If any event was lost in the past, then we can ensure that, the service tokens are funded. So the user deposit contract, which actually is used to pay for PFS and monitoring service, is funded. So here I'm requesting the user how many tokens they want to deposit, and then yes, like that. So yeah, and here I can ensure that there is a channel open. In this case, I'm asking using just window.prompt, so it's the simplest possible approach, just to demonstrate that I can just ensure that the channel is open here. In this case, I'm suggesting this hub that I just have shown to you guys, and then the amount to deposit. And once this is done, once the client is started, I can just perform a transfer. So I'll show it to you here. I can start the client. MetaMask will ask me to sign that same message in order to generate the delegated account. This is deterministically generated from the main account. So it's just the hash of the signature of this message here. Once you sign, it will sync. And as you saw, it took like 2 or 3 seconds to sync with the blockchain. So it's quite fast. Now I can perform transfers. This simplest dummy application will ask who I want to transfer to. So let's say that I just want to transfer to the hub that I have a channel with. It could be your node. It could be any node online on the blockchain, on the Raiden network right now. We have methods to suggest partners here as well. Let's just transfer 0.01 tokens. So it's transferring, exchanging messages. Yeah, we can see here the transfer was successful. It did not show a dialog, but we could have just create a dialog here, like alert transfer to show success. But from the logs here, you can see that the transfer was successful. A full-fledged client like the DApp will have a proper dialog, as I have shown to you guys. But yeah, this is enough to have your transfer going. So let's try a different one. Now a mediated transfer to this other node here that I have online on the same token network, right? So let's copy its address, then perform a transfer. I will paste this client here address to it. You can see here the I need to just reload this because this does not have fallbacks, but on the DApp you have a full-fledged application. This is a light client written like 70 lines of code. So yeah, this is simple, but on a full-fledged client you could implement all the error handling that you should. So yeah, let's start. It syncs quickly. You can perform a transfer, paste the address. Let's see, I want to transfer 0.2 tokens. And then it will perform now a mediated transfer. Because I don't have a direct channel with that node, but this just worked. So you can see here, the transfer got received, even though I don't have a direct channel with that node, I just have a channel with the hub. So of course, this is their payment channels network is a very powerful approach, especially for IoT and use case that require fast, small, and often transfers. And this is the perfect use case for payment channels. And the Light client and Raiden network is already ready. And the main Raiden Python client is already deployed on mainnet, so you can use it right away, right now. And the Light client is not yet green light to the mainnet, but you can hack on it on there also if you want. And you can also test it on Gurley as we are doing here. So just start and transfer after you get onboarded, which is the expensive part, but this is property shared by all second layer solutions right now. We are trying to check on improving that. But after you are onboarded, the user can perform as many payments as they want, free, fast, and cheap. Fast, cheap, and scalability on the Raiden network of payment channels. That's it from me. Questions, remarks, anything that I could help here? What do you guys think?
Thank you for that demo. That was awesome.
There was one question, if the receiver has to be online.
Yes, the receiver has to be online, mainly because it's required that the receiver sign messages in order to request the secret from the initiator, or else the initiator is not going to reveal. If the initiator reveal the secret to anyone else, they could get robbed. So it's needed to sign this message. And this is what gives the security features of the Raiden network, where you actually only paid what you signed for, not what you deposit. So deposit is only a backing of the transfers. Once you have it backed on chain, you can sign the balance proofs off chain and you safely perform these transfers. But yes, without the payment channels, the receiver needs also to be online. But with transfers taking even less than 1 second, this is usually not a big problem, because we have we can have sub-second finality on the Raiden network. So as soon as the transfer protocol was completed, as soon as you verified the signature of the message that you have received, you can be 100% sure that we will get paid. This is the security feature of this network. So even Ethereum 2.0 solutions, they do not provide this property. So actually, we are looking forward to Ethereum 2.0 because it will reduce a lot the cost of onboarding users on our solution. But payment channels, state channels, payment channels is a specialization of state channels. Solutions are actually complementary to sharding and rollups strategies for scaling Ethereum. So we are looking forward to that. They both will work great together, hopefully. More questions? So someone asked here, how does Raiden avoid the gas prices? Well, unfortunately, it can't yet. This is an issue for all second layer scaling solutions. Everyone needs to onboard at some point, and to onboard, you need to pay gas for that. And to offboard, you also need to pay gas usually. So this is a problem that we are actively working towards improving, because right now you need to pay for onboarding the user. So the user needs to onboard, they need to open a channel on chain, they need to lock the tokens in a deposit on chain. But after they have done that, they perform the transfers fully off chain as often as they needed. You could perform 10 transfers per second without batting an eyelid. So it would work fine. For example, for IoT devices working and paying for energy, or for paying for megabytes of data downloaded or uploaded, or to pay for minutes or even seconds of video watched. You could implement this with Raiden. Small, scalable, fast payments work great for it. But yeah, to onboard, it's still a little bit expensive. Yeah, so I gave here 2 examples mainly. You can use the dApp directly as a user or as a developer by pointing the user as a paywall, for example, to the dApp, and then the user will be able to use their already instantiated Light Client dApp account in order to pay for your specific request. Or you can implement the SDK directly, which opens all the doors possible. This works on Node.js, this works anywhere that JavaScript can. And then you can implement your own client without having to think and to ensure all the safety guarantees that Raiden provides. So the whole Raiden protocol is implemented in the Raiden-TS package, and you can use this on your application right away for IoT, for web, anywhere browser or JavaScript works, it should work. So you put an X amount paying fees once until you don't spend all X covered for payments. So yes, hopefully if you can lock a amount high enough, and you have this specific use case where you perform many payments, small payments, after several payments, of course, you already have gained what you would on gas fees if you were doing all of those transactions clogging the network. Another property of state channels and payment channels is that only the latest transaction goes on chain, so it adds privacy. No one needs to know every small transfer that you performed. You only the latest final amount is settled on chain and needs to be visible on chain. And even that we are looking on solutions to improving that using zero knowledge alternatives and algorithms for this. So project suggestions for it. Hackathon. I think we have published some of them. Jacob has been working on that. There are several alternatives that goes into the direction of integrating Raiden with the latest on-chain scaling solutions like rollups. This would be great to see something in that direction. The smart contract part of Raiden is just a smart contract. It's not special in any way. It's just a normal smart contract. So you can optimize that using the standard solutions out there. But if you want to implement also use cases, actually using Raiden for end users, that would be great as well. For example, paywall solutions, pay per view, pay per minute, pay megabyte, or maybe even a small robot paying for its energy or its connection link using Raiden. That would be something quite interesting. Yeah, so Jacob has shared the link that would help on that. So yeah, about the Argent token, this is interesting topic. It's mostly related that we wanted to support any token network. Of course, right now it's quite a little bit limited the number of token networks that can be used. On mainnet right now it's DAI and Rapid Ether, but we want to open that for everyone. But not every token is useful for the service providers. So it's important that the service provider use a centralized or a shared token that they know that will work regardless of in which token they are serving their services. So this common denominator, this centralization point for value on services provided on the network needs to be stable, and that's why we have chosen a specific token for that.
All right, we are a little bit past time. I want to be conscious of everyone's time here. So thanks so much again, André, for showing that very, very cool presentation. Very informative, very educational, very good, clear presentation. And as always, if anyone has any questions, please feel free to ask on the Discord sponsored Raiden channel. And I'm really excited to see what everyone builds off of Raiden.
Thank you, guys. Thank you very much. And looking forward to see all your guys' ideas and projects implemented on top of it.